All right, welcome back. Now, we're going to talk about some things we are already aware of, or we hope we're already aware of. The first thing we're going to talk about are natural numbers. Now, natural numbers we're most used to thinking of as the counting numbers. And just how we count when we're playing hide and seek, and you start counting, you go 1, 2, 3, keep on going. I'm not going to keep on going because that's going to be forever, right? It goes on forever. So these are what we call natural numbers. Now, not something normally in developmental math 1 would you be tested on, but future math would stress to you the set notation. So the set n, and that's a black boldface n, I didn't go crazy here with the 2 lines, they're supposed to be there, is equal to the set of the natural numbers 1, 2, 3, and they're separated by commas telling you each one of these are an element of the set, and it goes on forever. And that's our natural numbers. Whole numbers is the natural numbers, or the counting numbers, but we added an extra thing, plus 0, or what I always like to think of plus the whole, so to speak. And 0 kind of looks like a hole without the W, right? Okay, besides the point. So we start at 0 and we head our way up. 1, 2, 3. Keep on counting until you're blue in the face. And it goes on forever. And the whole numbers is denoted by the black boldface W is equal to the set of all elements. 0, 1, 2, 3. Keep on counting. The dot, dot, dot here is an ellipses, and that means continue on in this fashion. Next up, we're going to talk about integers. Now, integers are interesting. Usually we have a starting point in the middle, which is 0. And we can go to the positives, 1, 2, 3, keep on counting until you get blue in the face, right? But now we also have the other direction. Notice the arrow going the other way. We can head into -1, -2, -3, and we keep on going down. As we go to the left, we get smaller. And when we go to the right, we get bigger. And that's just how our math world works. If you want, maybe not the most politically correct way to remember this, I always think of the left as Democrats, and usually they prescribe to people who have less or smaller amount of money, and the right are conservatives, and usually, and I'm stereotyping here, they prescribe to people who have a bigger amount of money, a lot of money, right? Not necessarily, but I'm just stereotyping. That's a way to remember it. So moving on before I get in trouble for legal issues, let's talk about order. Now, order is greatly dependent on the number line I gave us earlier, so I'm just going to fill it out here. So here is our beautiful order, in which things that are to the right on this lovely number line are much bigger than the things that are to the left. So, for example, we have the inequality symbols. This guy is greater than, and this guy is less than. And what they tell us is who's bigger. So if we were to compare -5, ooh, that looks ugly. Let me erase that real quick. If we were to compare -5, and I'm going to write a box here, to +5, it's like, which one would you rather have? Would you rather have $5 or owe somebody $5? I personally would like to have the money, so the alligator, like the hungry alligator, faces towards the bigger guy, and that tells us order. So we can say -5 is less than 5. And that's just it written in words. So that's what this symbol means, is less than. The same statement could be true if it was reversed the order. And let's say we have 5 compared to -5. Now we've already agreed we would rather have $5 than owe somebody $5. So 5 is greater than -5. But now it reads differently, and I used a different symbol. I used the greater than symbol. So we say 5 is well, I don't know what I wrote there. Let me erase it. We'd say 5 is greater than -5. Now these were easy, and I intended that to be so. Let's do 2 somewhat hard ones, and then we'll call it even. So we're just going to fill in the box. Let's compare these 2 numbers. Let's say -3 compared to -10. Now, at first impulse, a lot of students think, well, 10 is bigger than 3, so that's bigger. And that's not the case. Because of the negative signs, this changes things. So I go back to asking you, which one would you rather have? Would you rather owe $3? Or would you rather owe, and that means like you're in debt, $10? I would rather owe $3 because technically I have more than when I would owe $10. So -3 is much bigger than -10. You could even see it on the number line if you don't quite believe me. So let's say -3 is here, then we continue down, -4, -5, -6, -7, -8, -9, and last but not least, here we are, -10. So, when we compare these two, -3 is further to the right than -10. So -3 is bigger because it's further to the right. And that's it.